Okay, question number 38. Which of the following statements is correct about the part of circuit within the area surrounded by the dotted line? Right here, this part. So they're asking about what is this part. It implements half adder. Yes, very true. Because this is actually so combination of two half adders. So it is half adder. It can be implemented using AND and OR gate. True. It can be implemented only using AND and OR gate. It can be implemented using only AND and OR gate. It can be implemented using only NAND gates. No. It can be implemented using AND gates, OR gates, and can be implemented using NAND gates, NOR gates. So basically, universal gates can be used to implement that. So only using NAND gate, OR gate, no. Only using NAND gates, no. So other gates are also possible in implementing that. So one only is the correct answer for 31. It is answer number 1. 31, it's answer number 1. Sorry, 37. 37, it is answer number 1. Okay, the next. Consider the following K-map, and they're asking about the logic expression or Boolean algebra expression. Can you answer the question number? Okay, question number 39 quickly. Question number 39. Previous one was asking, yes, previous one, what about the answer number 3, 38? So here it depends on how you read this, right? So it can implemented using only NAND gates. So there is a confusing one, yes, I also thought. So it can be implemented using only NAND gates. That is true. But it can be implemented only using NAND gates. So that is there, like the word. So when you're reading this, the difference comes. It can be implemented only using NAND gates, false. NAND gates වලින් විතරක් මේක හදන්න පුළුවන් කියලා ගත්තොත් false. හැබැයි මේක දීලා තියෙන විදිහ අනුව කියමු, it can be implemented using only NAND gates. NAND gates වලින් විතරක් මේක හදන්න පුළුවන්ද? Yes, true. Using NAND gate, because NAND gate is a universal gate, no? Using NAND gate, you can build that. Using NAND gate, you can build that. Therefore, you can consider that as the correct answer. But it can be implemented using only AND gates and NOR gates. Then there's a problem. AND gate is okay, OR gate is also okay, but you need support of NOT gates also. Without support of NOT gates, it is difficult. Therefore, you can consider the 2 as wrong answer, because AND gates, OR gates, and NOT gates is also needed. So in that case, you can go to answer number 4. But that depends on the, right, it is basically the way that they have presented the answer. That is the problem. So if the idea is, so this can be implemented using like NAND gates only implementation is possible for this? Yes. Using NAND gates only implementation, you can do this because NAND gate is a universal gate. Right? NAND gate is a universal gate. So you know what is universal gate? Universal gate means NAND gate can be used to implement any of these gates. So only NAND gates you can implement, only using NAND gates you can implement any gate. That is why it's universal. This answer is correct for any. So let's see this. Logic.ly. I'm using this website. Go to this website. And let me show this why I'm telling like that. NAND gate. This is the NAND gate. Right. Let's try to implement NOT gate using NAND gate. If I use a switch and if I combine these inputs, right? NOT gate is basically inverting. If I connect a bulb, NOT is inverting. That means 0 is 1, 1 is 0, 0 is 1, 1 is 0. You can see that can be implemented using NAND gate. NAND gate can be used to implement NOT gate. Right? That is why I'm telling it's universal. And same NAND gate here can be used to represent AND gate also, because AND if you send it using if you send it through the NOT gate that you have already created here, now it's acting as AND gate. Why? Because this is NAND. NAND is basically 1 and 1, 1 and 1 will become 0 there. Here it's not going, but the 0 will be knotted and it will become 1 again due to this implementation. So 1 and 1 is 1 means AND gate. All other occurrences 0. You can see 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. 1, 1 is 1 means it is AND gate. So using NAND gate, you can implement. Using NAND gate, you can implement AND gate also. And using NAND gate, you can implement OR gate also. That is why this statement can be considered as a valid statement. True, very true. Thank you for reminding that. So if you read that way, so actually that is the way it's given, but it is a bit confusing. That is why I dropped the answer. But so that is also true, because using NAND only you can implement anything. Therefore, using NAND you can implement this one also. See here, this is OR gate. This is how we can implement OR gate using NAND gate. You know the behavior of OR gate. If both are 0, oh, what has happened? This is okay. Oh, did I do something? I have to use NAND gate. Sorry. It should be NAND gate, not AND gate. See here. So 0, 0 is 0. 0, 1 is 1. 1, 0 is, that is also 1. 1, 1 is also 1. So that is the implementation of OR gate. Both 0 and 0. Otherwise, it's 1. Or not any other occurrence, it's 1. That is the implementation of OR gate. So you can implement NOT gate, AND gate, OR gate. Any gate using NOT gate, AND gate, OR gate. Any gate using NAND gate. Therefore, you can even implement this using NAND only. Using only NAND gates, only NAND gates. Only thing is why they have written like that. It can be implemented using only NAND gate. Using so bit confusing that is how they are written. Anyway, so you can get that idea. Yes, using NAND gates, you can implement that. So 1, 3 is correct. Therefore, the answer is 4. But this is only using AND and no. Only is using AND and no, you can't, because there is XOR. XOR, in order to implement XOR, you need NOT gates also. Therefore, this is wrong. Without NOT gates, the answer is wrong. That's that. That is it. 39. Let's see the K-map solution. So K-map, you have to think about the groups. They have group zeros. If you are grouping zeros, you have to consider about OR gate. Output in 0 from the OR gate. This group, what is unique? You can see C is already 0. So we can take C as it is, because C is already 0. So C is useful. And C is unique, because here also C is 0. Here also C is 0. In the both points, C is 0. This point also C is 0. This point is also C is 0. So C can be taken as a variable. It's a constant. And here you can see A is 0. And here also A is 0. For both A is 0. So A can also be taken as a variable. So you can get this as A or C. because OR gate, when you are considering this K map, if zeros are grouped, then it is O. If ones are grouped, then it is AND. Okay, what is the next group? Next group is these two zeros. C is varying, but you can see A and B are 1. But A and B are 1, problem is both are 1. A and B are 1. When both are 1 only, this is 0. That means you cannot take pure A and B. You have to get the other way. Both are not 0. No, therefore, these ones you need to convert into A naught or B naught. And then you have to AND both. This one and this one. That is a valid answer. Is there any way? Anywhere you can see this? Yes, that is this one. A or C, A naught or B naught. So that is the K-map solution for this question. So 39 answer is number. For 39 answer is number 4. So what about your answer? Oh, Varun is 3 now. It's 4. 39 is 4. Senal, did you give the answer? No. You didn't try. Why? You don't know how to group zeros?
I did, sir.
You found this answer or any other? Yes.
Yes,
So
sir.
another answer you can take by grouping ones. So let's take that also. Let's group ones. Here you can group ones. So if you group ones, what is the answer there? So you can see C is constant. And here C is constant here. C and here A is constant, but A as 0. So we can say A naught and C is one variable. Because C is constant, it's 1. And here A is 0. So you can take A naught because this is considered an AND gate. And the next group is this one. So let's consider AND gate, and you can see C is not a constant, but AB constant. So how AB are constant? So A as 1 and B as 0, so B naught. And if you AND both, if you O both, then you will get another correct expression, but not for the 0 groups. This is for the groups, 1 groups. Not for the 0 groups, for the 1 groups. A naught C, you don't have that answer. A B naught. A naught C, A B naught. A naught C, A B naught. Actually, if you solve this, still you can get this answer, right? If you try to solve this one, you can obtain this answer too. Why? Use the distributive law. If you use distributive law, you can see this A is, you can multiply or you can just apply A O to this one. So then you will have A O C. No, you just apply this part. So just think this as X, this everything as X. Then you can say X A naught, X A naught, or X B naught. So you know what this X is? X is basically A O C. Then you have A naught. Then this X is again A O C. There you have B naught. Let's solve this further. Then you can write A naught C, A naught C. Then the next one, A B naught, and C B naught. here you can write this as A naught is anyway 0. 0 or something is that thing. So you can write A naught C there. Then A naught C is there. A B naught is there. Then C B naught is there. A B naught is there. Then C B naught is there. So there is another one. Actually, here B naught is common. You can take B naught out, then A or C. That won't give the answer. Then if you take this one, is there anything common? No. But so solving this is not expected here. But I just said you can obtain this one 1 by. So this is the other part. Like you should take 2 by 2 using AND gate. You can obtain the product of sum expression and sum of this product of sums. This is sum of products. Okay. Anyway. Right. Let's move to the next one. So that is about this flow chart. Question number 40 and 41. 40, 41. Question number 40 and 41. Please answer question number 40 and 41. Consider following flowchart given in flowchart to answer the questions 40 to 42. 40 to 42, you have to answer the flowcharts given below. And start I equal 8, result equal 1. So in these cases, I said how to answer these kind of questions. You have to make boxes, right? So the easiest way is create some boxes. Create some boxes means you can create a box called I. Okay, let's draw this. So let's create a box called I and put that variable there.
Excuse me, sir.
Yes.
The screen is not shared.
It's not sharing. Let's try again. Okay, can you see it now?
Yeah. Now can see.
Right, let's create boxes. You have two boxes. You can create like variables are the value, like variables are the places where it holds a change in value. It keeps a change in value. Right? The variables keep a change in value. Therefore, you can create a box to store this variable. Okay, let's say there's a variable called I and I'm allocating a box to I. And there's a variable called result and I'm allocating another box to result variable. Result variable. There's a variable called I and it's a result variable. Right? Then I is there, the result variable is there. Right? When I is there and the result variable is there any other variable? N, input N. This N actually we don't know, but still you have to put box to N also. Still it's unknown. And then based on the N, you have to manipulate the result and then finally put the result as the output. How to do this? I is 8 initially. I is 8 initially. So let's put that value 8 there. I is 8. Result is 1 initially. Result is 1 initially. Let's put 1 there. Right? Input n. Input n is unknown. Right? N is unknown, but you are checking whether n less than or equal to n. Sorry, n less than or equal to 0. So if it is a negative, you do something, you deduct 1 from that. But if it is a positive, if it is a non-negative, if it is greater than 1, so if it is greater than 0, 1 or above, so that will be multiplied, the current result will be multiplied by that n. That means if you get a negative number, you skip. Negative number, skip and go into the next step. But the positive number, then multiply. That is this algorithm is. If it is a negative number, if it is negative, yes, you skip it. And just deduct 1 from I, where I is 8. This is going to run until I is less than or equal to, this is going to run until I less than or equal to 0. When I becomes 0, it will stop. So starting from 8. 8, then 8 minus 1 is 7, repeating again, 7 minus 1 is 6, repeating again, likewise, repeating. And when I becomes 0, it stops. Okay, let's see what will happen. So what are the answers given? What are the answers? The answers, it takes 8 inputs. Is it 8, 7, 6, 5, 4, 3, 2, 1, right? 1, then after that 1, after that 0, but when it becomes 0, it terminates. Therefore, it takes 8 inputs, correct? If output of the product is positive, it output the product of the positive numbers in the input. Very true. It output the product of the positive numbers, plus values. That is true. And if every input is 0, then the output will be 0. If input is 0, yes, it's not multiplying, but still the output is 1, right? Because it is 1 initially, it's not 0, it's 1. Therefore, A, B correct. A, B correct. A, B correct means the answer is number 4 for 40th. It's number 4. 40th. It's number 4. And 40th, number 4. And then 40th, it's number 4. 41. So what about 41? Question number 41, if the following is fed as the input to the system, what will be the output? It is multiplying the positive numbers. We learned the algorithm. It is multiplying the positive numbers. Three, 2, minus 4, 4, 1, 5. So let's multiply. 1 multiplied by 3 is 3. 3 multiplied by 2 is 3 into 2 is 6. 6 multiplied by 4 is 24. 24 multiplied by 1 is that. That multiplied by 5 is 120. So 41, it is 120. It is number 3. It's easy. So once you discover the algorithm, it's easy. So your answers are correct. Okay, your answers are correct, Shanali. So let's move to the next. So try to stay connected, right? Everybody try to stay connected. I'm not sure. So because some students are not coming to the classes regular basis, like I'll note them. So then I will not send the recording to them. So if they are adapted to this style, because they know that the recording, I will take the recording and they take this as a granted. And that then why I'm doing a online class? So there is no point doing online class. Because if they always want the recording, I have all the recorded lessons already. I can send it to you and watch at that week by week. Don't take that as a granted opportunity. Then 42, 43, 42 and 43. So try to calculate the answer. 42 and 43 quickly. Which of the following Python programs has the same functionality? The same output for a given input as an algorithm in the flowchart above. Right? So they are asking which of the following provide the so which of the following is giving the output which is given in the flowchart. First one is starting with I8 and result is 1, and while I is greater than 0, you are getting the input multiplying, and I minus 1, you are going up to 8, 9, starting from 8. So 8, 7, 6, 5, 4, 3, 2, 1. Okay, because while I greater than 0, 8 times, the A is correct. You can take A as the correct one, 42. And then B, result is equal 1, that is also okay. For I in range 8 means it's running 8 times. No doubt it's running 8 times, and no need to even, so you are checking whether this N is like input is a positive integer, and if it is multiplying, yes, B is of course correct without any error. So starting from 1, starting 8, while I 1 means it is running infinitely. You have to break somewhere. You have to break somewhere where in which point you are going to break. You are going to deduct 1 from this, and when it is less than 0, it breaks. Less than or equal to 0, yes, not just less than or equal to 0, it breaks. That means this will also run 8 times and get in the input, and if it is not negative, not negative, yeah, here they are checking the other way. Yeah, they are not checking the positive, no, they are checking not negative, the multiplication. Yes, that is also correct. So all AB3 are correct answers in 42. All ABC are correct answers in. Which of the following statement is correct? That is in right. High-level language is a program that is translated into machine code and executed in a computer. A high-level language program is translated into machine code and executed in the computer. X will not execute on another computer having the same processor as X. So what is that? A high-level program that is translated into machine code and executed on a computer. What is this X? X will not execute on another computer having the same process.
That is
Okay, let's keep that point. A program in high-level language must be converted into assembly code before converted. No, not a must. Not a must. Interpreted program runs faster than the compile. No, the other way. Compile run faster. Program is some high-level. Programs in some high-level languages are translated into a form called bytecode because such bytecode execute faster than the machine codes obtained by usual compilations. No such thing. So it is true that it is converted to bytecode, but that not because it is running faster than the machine code. Because like it is like for the platform independent, Java does that. It is converted to intermediate code called bytecode, and the bytecode is easy to execute. But it is not faster than machine code. Machine code is faster. Some modern processors execute program in high-level languages with no processors are executing high-level languages. All are translating to the machine language. So this is wrong. This is also clearly wrong because this is it's not that bytecodes are faster. Still, the machine codes are faster. Compiling is faster than interpreting. Here it is also wrong. The program must be converted to assembly language. No, not really required, but can be converted, but not a must. Then high-level programming language is translated to machine code and executed on computer. Yes, computer X. So I was wondering, what is this X? High-level language program is translated into machine code and executed in computer X. Will not execute it on another computer having the same process X. Cannot say like that. It can execute. So no correct answer is there, right? So what about the marking scheme answer? So let's see the marking scheme answer for 2019 paper, because 43 no answers are there. A-level ICT 2019 marking scheme. No
So
matter
it says
signal,
vote.
let's take it. It's 2019 paper, I guess. Okay. This is a bit doubtful because we had a few questions which are doubtful in this 2019 examination. Do you have the answer there? Question number 43. Yeah, all. No specific answer, it's all correct. Our prediction is correct, no specific answer. 44, 45, 46. Kindly answer 44, 45, and 46. Okay. (47) also you can give a try. Right. What is the value of following Python expressions? 100 floor divide by 3. Floor divide can integer division. Floor divide is basically integer division. Then modulus, and finally take in the operation. So I think you can remember the order. BODMAS theory is somewhat applicable. So first the brackets, then right brackets, then here you can see brackets will happen, then multiplication, division, those things have same level or power is basically having a higher level. Then you have even before that the unary operations, that means Norton, and unary means one operator, one operand. Not operation, minus 1, -2, like things, these will be considered right, -1, -2, like these things will be considered first, and after that multiplication, division, modulation, all these things same level. But if all are there, then left to right will be executed. Finally the bitwise operators, here you have bitwise also. 100 floor division by 3, integer division, it is 33. Modulus by 4, what is remaining? 32, you have 8 and remaining 1, so 1 is here. 108 is, so it is 9, right? If you write that 108, 8 is 1000, 1 means 0001. If you owe 1 0 1 1 1 0 0 0 0 0 0 1 or 0 is 1, that is 1001, which is 9. Right. Therefore, the answer is number 5. So, what is your answer? Your answer is also number 5 for the 45. Okay, correct. I'm okay with you too, because like you are doing well. But the problem is with others who watch the recording and they are not in the class even. So no point talking about them too. Right. Then the next one, what will be the output? The following code executed: A, B, C as the input. Result equal 1, S input, length of S is greater than, what is the length? Length is number of characters, 1, 2, 3, 4, 5, 6. Greater than 3, yes, then result is 2. S is greater than 3, yes, result is 2. S is result is 3, so result is 2. S can high, length is 6, greater than 3, result is 2. Then length is less than, if length is less than 6, it's not. If the length is greater than 6, if the length is greater than 6, it will automatically come, because these ifs are not connected. You can see this is individual if and this is another individual if. This will be considered and result is 2 for sure, yes. But it will come to the next if as it is independent. If it is less than 6, no. If it is greater than 6, it's also no. Then it's go to the else part, because it is not less than 6, it is not greater than 6, it is exactly 6. Therefore, result is 5. That will be printed, and 5 is the answer there. Okay, that's it. And the next one. So what is the output of the following? This paper, I guess it is easy. These Python codes are easy. What will be the output of following Python code? X is 100. For I in range 1 to 5, it's 5 times. X equal X minus 1 and print in X. What is X? X is 100. 1 to 5, x minus I, 1 is deducted, 99. From that, 2 is deducted. Second time, 2 is deducted, 99 minus 2 is 97. From that 97, 3 is deducted, that is 97, 94. From that 94, 4 is deducted, that is 90, but it's not going to up to 5, so it's 90 ultimately, so you'll get 90 there. Question number 46, 90 is the answer, so answer number 4, correct. Answer number 4. 47, I think you can try that now. You can finish the paper, right? It's easy. 47, 48. 47, 48. What will be output of the following Python code segment? There's a list given, x equals 0. For I in range, length of L. What is L? Length. Length of L means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Length of L. So Li is less than 0, continue, you're skipping. If it is a negative number, you're skipping. If you are a positive number, what's going on? If it is a negative number, you're skipping. If it is greater than, if Li is greater than 10, you are breaking. Right? Otherwise, you are adding. Right? So that is a bit confusing, right? Okay, so what will happen? If Li, if the element is less than, if it is a negative number, you continue. Continue means you are coming back to the next stage. You skip that stage and go to the next stage. But if it is greater than 10, you skip and exit from the loop. Right? The exiting point, especially when it is 11 here, it will skip, it will exit. So what will happen? It's adding then x, it's adding the list item to the current x. Current x is 0, 0 plus 1 is 1. That minus 2 will not be added because it is continuing skipping that step if it is minus number. 1 plus 4 is 5, 5 plus 3 is 8, plus 2 is 10, 10. Is it? I hope it is 10,
Yes.
right? Should be.
Yes.
Okay. Because like it is, when it is 11, it is skipping and it's not going to calculate. So that will be. So next is 48. 48, 49, 50. All three you can do. Let's finish. Okay, x equal 50, def function f y is declared. Y is given as the input. What is this y? Y. Okay, anyway, x is equal to 2 and y is equal to 4 in this. x2, y4. Function x will take this x as the input. So x will be fed and you are printing x. When you are printing x will be 50 because x is 50, right? Because this function, the x and y are local variables. It's not telling like those are global. If it is global, you have to say global x. Global x, global y, global x may x venas wenna ona. But this x and y inside the function are local to it, and y is a parameter, it's also local. So you can give this y, you can give function x, and that will be this 50. But even though you give that 50, it will not be altered here. It will be altered, but inside the function, outside the function, still the same value, so it is 50. So that is the point here. For 49, which of the following is not an information stored in a process control block operating system? Free disk slots. Free disk slots, basically, you are not storing that in the process control block because that is related to the process, and the memory management related to the process. Memory management information for the process, yes. Program counter, yes. You need to keep that because that is the place that you are like in program count is implemented. That is where the tracking of the program is done. Process identification number, the PIN, yes. Process number is a unique number that should be there in the process control block because that is using that only the end tasking and accepting or terminating. All these things are done using this unique ID file. Process state, yes, ready or blocked or terminated, etc. will be also stored. So 5 is correct, 4 is correct, 3 is correct, M2 is correct, but free disk slots, no, that is disk blocks, no, that is 1. So not an information, it is 1. Consider the following SQL statement: update school set contact person Sripal W where the school ID equals 4. That is basically update query. It's a data manipulation query. Yes, it's a data manipulation query or update query. Then it adds additional field. No, it's adding. It's not adding additional field. It adds additional value to the contact person as Sripal W. Only it add additional value to the contact person Sripal W only in the records having school ID 4. No, it's not adding additional value. No, it is updating. It changes the field name. Not changing the field name. It changes the value of the contact person. Contact person. Yes, it changed the value of contact person Sripal W only records having school ID 4. Yes, that is true. Because it's changing, it's updating the data. It's select all the records having school ID 4 and contact person as no, it's not selecting, it's updating. So it is number 4. Okay. So it's very, I can see it's very good if you have done this along without referring to the marking scheme and all. Your knowledge is, I'm really happy about this, and I think that now MCQ papers you can do easily. Let's do two more papers, that is 2020 and 22 papers. 20 and 21 papers, only those two. When is the examination? Is there any changes or is it same? Senal?
Same dates, sir. On 23rd of January, it's going to start, and we will be having
IT?
IT on 13th February.
13th February. Saturday 10th means now we have like speed up the lesson discussion. 17th. So let's try to quickly go through the next paper, 17th. Okay, then the next week is Christmas, I guess. You can skip that week, just take a rest and continue to the next week. Yes, next week within this year, try to finish MCQ parts. Actually, so essay part is not a difficult thing. Once as MCQ is discussed, the essay part we can discuss one paper and get an idea about that. Yes, it's enough. We can do. Right. Okay. With this, if you are really up to this polish, I'm pretty sure that you can get A pass. But don't be like I'm not overrating you. Practice and practice, practice and practice. Because even though you are writing the question paper in the classroom, sometimes you are afraid in the examination and committing and selecting wrong answers. That can happen. Therefore, be careful. So practice harder and be confident about your knowledge. Then no matter whether you're pressured or no matter whether what situation is, you will write the answer. Okay. Okay then, good night. Bye.
Thank you.
Thank you, sir. Good.